Welcome. I'd like to give some mini lessons on section 12-3 of Pre-Calc. The first section I want to talk about is how to find our reference theta. So I'm going to give a few examples. First of all, if theta equals 135, oftentimes we need to find a reference theta to be able to work with that angle. So to do that, you need to first sketch the angle 135. Notice that 135 is in quadrant 2. The reference theta is an acute angle in the reference triangle. Here's how to sketch the reference triangle. Go from the end of the terminal side of the angle you just sketched, drop a perpendicular to the x-axis. Always drop your perpendiculars to the x-axis. The reference theta is this angle right there. So I need to figure out how many degrees it is. I know that this line is 180 degrees from here to here. With that in mind, theta reference is equal to 45 degrees. Okay, let's do another one. Suppose theta is 300 degrees. Let's use 330 degrees. So now I need theta reference for that. Sketch the angle. Hopefully you realize that 330 degrees is in the fourth quadrant. So I sketch it. Showing 330 degrees. Now I drop a perpendicular to the x-axis. My reference theta is right there. So, theta reference equals 30 degrees. Reference thetas are always acute angles. Let's do one more. Theta equals negative 120 degrees. Sketch the angle. Negative 120 is in the third quadrant. Negative 120 degrees. Again, I need to sketch my reference triangle. Go from the end of the arrow to perpendicular. Always perpendicular to the x-axis. My reference theta right there. What is that acute angle? Degrees. Notice reference thetas. Always positive, always acute. This next section is on finding the 6 trig functions of the acute reference angle of different thetas. The first thing you need to do is think about what quadrant the angle is in, and that determines whether the angle is going to have a positive or negative sign on one of the 6 trig functions. I have a special code for remembering this. I'll give it to you now. Think of the quadrant system, and as you know, we have quadrants 1, 2, 3, and 4. The trig functions, depending on the quadrant, are positive or negative. The special code. All students take calculus. All students take calculus. What that means in terms of the special code is that all trig functions are positive in the first quadrant. In the second quadrant, the sign is positive and its partner function, the cosecant. In the third quadrant, the tangent and its partner function, the cotangent, are positive. All other trig functions are negative in this quadrant. In the fourth quadrant, the cosine is positive and its partner function, the secant. And again, when you do the 6 trig functions, I'd like you to write them in this order, in this sort of chart. Sine theta, cosine theta, tangent theta, secant theta, secant theta, cotangent theta. Writing them in this format helps you remember that if the sine is positive, so is the cosecant. If the cosine is positive, so is the secant. Tangent positive, cotangent positive. Now, let's see if we can use what we learned about finding a reference theta and finding the 6 trig values, the exact values, which means no calculators, use the special triangles, the 30, 60, 90, and the 45, to determine the values of the trig functions. So, the first one we might want to do is 240. So, if theta equals 240 degrees, the first thing you do is sketch it in the coordinate system. So, 240 puts me in the third quadrant. Now, I need to find the theta reference. This is 240. This is 270. The reference triangle, right there, 60 degrees, always positive. So, I have this triangle, there's 60. I need the sides of this triangle to figure the 6 trig functions. There's my 90, there's my 30. Using my reference 30, 60, 90 triangle, I can now put the sides on this triangle. I know opposite the 30 is half the hypotenuse. There's 1, there's 2, there's √3. The tricky part, figure out where you have a positive, where you have a negative. Back in this diagram, from the center, moving that way, negative. From the center, moving down that way, negative. Hypotenuse is always positive. Keep that in mind. So, I can put my numbers up here too. 2, -1, -3. Okay, so let's do the 6 trig functions here in our little chart. The sine of that theta, opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. Tangent theta, opposite over adjacent. The reciprocal functions. Let's give a little more room here. Now, hopefully you notice that 2 negatives make this positive and this positive. Now, let's check our answers. What quadrant is that angle in? It's in the third quadrant. The only angle that can be positive is the tangent and its partner. Check. We got it right.